Welcome to EyeOpener, powered by Siemens. And now your host, Gugan Sanger.
What's some examples of how to scale predictive maintenance? What does that look like?
Yeah, I mean, there's lots of aspects that we can discuss. But I mean, what it looks like, is that people have got, a bunch of conveyors or robots or fans and things like this, and they want to be able to monitor it in a database way, predict whether things will fail, etc. And they're able to do that without having to climb over some huge barrier, right? So they don't have to bring expensive experts in, build custom models, build custom solutions, right? So it's like the increment of expansion, from zero up to whatever is sort of straightforward and can be handled by people who are close to the machines, basically, right?
So Natalie, to summarise this topic around data cleansing and preparation for PDM, what would you say are the 3 key learning takeaways that someone could take from this topic that we've just discussed?
So I would say the first one is that you need to provide predictive maintenance solution like Sensei with steady state condition indicators. And if it's not already like that, we can help make the data in that format. The second takeaway is that if there isn't something in the data to indicate a failure, the algorithms aren't going to find it. So we can work with little data, but the expectation has to be that we might not find everything unless you provide the right condition indicators. And then the last takeaway is that there's a huge benefit to onboarding many of the same asset type. So a whole fleet of assets, because you can gain a lot more insights than if you're just looking at one by itself.
What would happen if that data is not in the condition indication stage? What would happen?
So in the beginning of working with a customer, we have these sessions with them to kind of understand their asset types. So when we say asset, we're really talking about asset type. We're not talking about every individual machine because, again, scale. So what we do is we have these meetings with the customer to understand what the machine is, how it works, and what data tags or measures are available. From there, we have to figure out, now what do we do? So we have to understand, how does the machine fail? And how does it not fail? What does it look like when it's normal? The other key word, aside from condition indicator, is steady state. So we want the data, basically what Sensei PDM is looking for is it's looking for data that is flat when it's normal and everything's going fine, and when it's not normal and it's failing, the data is not flat, it's doing something else, right? So it's just change detection.
Perhaps you can pick out some key insights that we could look to discuss in a bit more detail.
I mean, in terms of specific things that we could discuss as part of our solution, right? So one of them is the idea of decision support. So to me, a scalable system has to be a decision support system, and we can talk a little bit about what that means. The second thing, I guess, is you can never get rid of all the complexity in a system like this. There has to be some somewhere, but you have to locate it in the right place, as well as minimize it, but locate it in the right place so that it's not demanding too much of users, and it helps to support a trustable, understandable system. And then the third thing is, looking at predictive maintenance more broadly than an app or algorithms as like a way of doing things, or way of seeing things.
The first question I have for you is just around what are the key steps which need to be taken when it comes to data and PDM?
So this is one of the more complicated topics that customers and even people in my role who are just getting started, it's really hard to wrap your head around because there's a lot that goes into it. So in order to make the best use of PDM, data needs to be a condition indicator, and it needs to be in steady state. And sometimes we have to do work on the data in order to fit it into those 2 parameters. So some of the things that we might do are data aggregation, data transformation, and data cleansing. And sometimes we even need to provide context for that data.
If we talk about language models, what would you say are the main benefits of having those?
Well, in many ways, right? But I think of language models. It may not be formally true, but I think of them as being, a very rudimentary kind of artificial, proper artificial general intelligence, right? It's the only sort of technology that I've used, which is bringing with it a complex model of the world, an understanding of the user, an understanding of the kind of thing that it is, that it's an agent in an application, what have you, right? But yeah, and then an understanding of machines, the kind of things that happen to machines, et cetera, right? So it's being able to tap into that broad, world model that it's got inside, and the ability to connect that to local and specific knowledge, private, to do with your machines and all of this kind of thing, and previous interactions. And then, just to be a master of communication in the thing that's the most natural way to communicate for humans, and be able to do that, bilingually in, pretty much any major language, right?
To find out more, search Senseye Predictive Maintenance.